In this video, we will see how do we bring our matrix to a row echelon and a reduced row echelon form. So let us see what do we mean by row echelon form first. Echelon means it's a term that refers to stair-step pattern followed by non-zero elements of the matrix. And to bring a matrix in a row echelon form, the matrix must have the following properties. So, if a matrix has to be in a row echelon form, what all properties the matrix needs to possess? The first property that the matrix needs to possess is if there is any row consisting of all zeros, okay, then it has to occur at the bottom of the matrix. Okay, so if you have a matrix in which a particular row has all the element zeros, then that should be the last row of the matrix. The second property is that each row which does not consist of entirely zeros has to be 1. So the first non-zero entry in any row which doesn't have all the elements 0, it has to be 1, and this is called a leading one. That's the second property of a row echelon matrix. Then there is a third property that if there are two successive rows, leading ones, okay, then the one in the higher row is farther to the left than that in the lower row. Okay, so that's the third property. So if a matrix possesses all these three properties, then it is called a row echelon matrix, or a matrix in a row echelon form. Okay, a matrix is called as in a reduced row echelon form. So first you bring a matrix to a row echelon form, and from this form you turn a matrix to the reduced row echelon form. Row echelon form as a reduced row echelon form is that whichever column has the leading one in the row echelon form matrix, all the elements which are above or below this leading one should be 0. If that is the case, then we call our matrix to be a row echelon matrix. Let us learn this through examples. We have to tell which matrix is in row echelon form and which matrix is in reduced row echelon form. Okay, so let us look at the first matrix. First thing is, do we have a row with all the elements 0? So we don't have. If we have, that has to be the last row. Now the first non-zero entry in matrix A is 1. Correct? That is one of the properties of a row echelon matrix, is that every row should have the first non-zero entry as 1, and this is called a leading one. So that property is satisfied, and all the leading ones in the lower row should be farther to the right than the previous row. So we have this, the highest row, the one leading one is on the leftmost, then further right, and then the last row has a one further right, and hence this is in the row echelon form. Let us look at matrix B. In matrix B, we have a row of all zeros, and if we have a row of all zeros, it has to be last one. Is this the last row here? No. So this is not in row echelon. In the third, there is no row which has all zeros. Let us look at the first non-zero entry in each row. Leading one, leading one, leading one, and a leading one, and all of them are moving. All the leading ones are moving further to the right as we go down the rows, and hence it is in the row echelon form. Okay, let's look here. All the four elements are 0 and that is the last row. So that is the first property of a row echelon matrix. Let us look at the other rows. All of them have the non-zero entry as 1. So these are the leading ones, which with each row the 1 is moving farther to the right, and hence this is in row echelon form. What about part E? You can pause the video, think your answer. So in part E, we do not have any row with all the zeros. Let us look at row 1. It has got a leading 1, the first non-zero entry. But for row 2, the first non-zero entry is not 1, it is 2, and hence it is not in row echelon form. And here all the four zeros, last matrix, so first property is correct. What about others? In the other row, the first non-zero entry is a leading one moving farther to the right as we go down the rows, and hence it is in the row echelon form. So we see that A, C, D and F are in the row echelon form, and checking the columns of those matrix, the column which has the leading one should have all other elements 0. So if we look at the first one, we have a leading one here. These are zeros, but in this second column we do not have a 0 here, so it is not in reduced row echelon. Then let us look at matrix C. Here let us look at the column in which leading ones are there. Okay, all the column in which there are leading ones are these columns, and in these columns we see that the columns doesn't have all the elements as 0, correct? If we consider this particular column, then we have 3 and 1. In column 3 with the leading one we have element 2, hence it is also not in the reduced row echelon. Here we have the leading one, so all are 0, leading one, so in second column all elements are 0, leading one, so all elements are 0, and hence this is in the reduced row echelon form. And for F, I guess it is also in the reduced row echelon form. So I hope what are the properties that determine whether a matrix is in the row echelon form or in the reduced row echelon form is clear to everyone. And please note that a matrix in row echelon form is not unique. A matrix in reduced row echelon form is always a unique matrix. This means that if you perform permitted row operation on a matrix, you might be able to get different row echelon forms of a matrix depending on the operations which we have performed. But whichever form of row echelon matrix you are getting, if you try to convert it to the reduced row echelon, there will always be a unique matrix. Fine. So I hope what is row echelon and row echelon matrix is clear to everyone. If you have any doubts in this video, you can send me an email at kirti.mathacademy@gmail.com. This is my YouTube channel Mathacademy. If you have liked my videos, please don't forget to like, share and subscribe. Thank you.